Great. Hey, Miss Murphy, how are you? It's great to see you. I appreciate you being here. And today we are going to write balanced chemical equations. There is some example problems that we will work through. I have attached them to the material on Google Classroom. You should have seen that. You should have those with you. And we're going to get straight to business, okay? Writing balanced chemical equations. So taking in words and turning it into a balanced chemical equation. Great stuff. Great stuff. Okay, let me share my screen. Hopefully this goes well. Okay, just a few pieces of background information today, and it's actually very important, and I will continually stress this idea. So what you're going to want to write down, those are the examples we'll work through. So I'm just going to go to a blank sheet right here. As we get started writing balanced chemical equations, this is not going to be much, okay? We need to keep a couple things in mind. And I'm going to just say those are our diatomic molecules. All right. Now, di means two, right? This is a two. That's what di means. Atomic, atom, molecule. And it's actually two of the same atom. All right. There are 7 diatomic molecules, and you must memorize them and recognize them whenever they are present, okay? Now, we say Brinkel, Hoff. You see how if you were to read that, it says Brinkelhoff. Those are my 7 diatomic elements: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. All right, so what does it mean to be diatomic? What does it mean to be diatomic? Another way to phrase that is I could say, what does it mean to be a 2-atom molecule? 2 same atom molecule, and that's what a diatomic molecule is. Well, it means that for all of these 7 elements, whenever they are alone, they always come in pairs. All right, I'm going to demonstrate this several times. Another thing that means is we will never have BR. We will always have BR2, right? Like this, guys. BR, BR, 2, 4, 6. It works out perfectly like that. So 2 BRs together satisfy the octet. Bromine always comes in pairs. It's very stable. Iodine always comes in pairs. It's the same exact structure, right? 7 valence electrons, just like bromine, right? And you see the stability that comes in the pairs. Nitrogen is diatomic. Nitrogen has a triple bond holding it together. Very strong bond, but you see how it's stable. When 2 nitrogens are held together, we satisfy the octet. Chlorine looks like the other halogens with their 7 valence electrons that add up to 14, which allows for all elements to have, both elements to have their stable octet. We also have hydrogen, which is H2, right? H-H. You see that allows both hydrogens to have a stable octet. Oxygen, which is always O2, all right, has a double bond. Oops, I'm missing a pair. Let's make that 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 a pair. Okay. And O2 with a double bond, and then F2. All right. And F is another halogen. Each donates their 7 to make a total of 14. And that's just your straight up single bond right there. Okay, so these are your diatomic molecules. You can see why they always come in pairs whenever they are alone, because paired up, it satisfies the octet. Let's get straight to business. All right, I love this stuff. I love teaching this stuff. It's easy if you've learned how to write formulas. Okay, lithium hydroxide pellets are added to, that would be a plus sign, a solution of sulfuric acid, all right? Lithium sulfate, and is a plus sign. Water are formed, so that means it's after the arrow, they are products. Lithium hydroxide, this is ionic. We need symbols and charges, all right? Well, I happen to know that lithium is a +1, hydroxide is a -1, therefore lithium hydroxide is LiOH. The fact that they're pellets means it's a solid. All right. Next thing is I've got sulfuric acid. They tell me that sulfuric acid is H2SO4. Added to means plus, H2SO4. That is a solution. It is aqueous. All right. And then it tells me that lithium sulfate and water are formed. So they come after the arrow, they are formed. Lithium sulfate, it's ionic. That's lithium. That's sulfate. So what's that going to make? Li2SO4. It will be in the water. And then it says and water. So that would be and water. Okay. Now, that's wonderful. There's our equation. However, it is not balanced. So we need to balance it. All right, so we remember when we balance, we can put coefficients in front of reactants and or products. Now guys, this is the first hint I'm going to tell you. Okay, I tell this to my students every year. I need you to notice something. Let's look at our elements, okay? Because this is what we need to balance. We need to balance our lithiums. We need to balance, this is the easiest way to do it, is to balance our hydroxides. We will then make sure that our hydrogens are balanced, and we will make sure that our sulfates are balanced. Now I want you to see, please pay attention. I can compare my lithiums in the orange that are reacting with my lithium in the orange that are products. I can compare my sulfates in the yellow that are reacting with my sulfates in the yellow that are products. What that leaves left over that I cannot compare to anything is my hydroxide and my hydrogen, okay? So I want you to look at a hydrogen and a hydroxide, and it makes HOH, and that makes H2O. I'm going to confuse. This is a horrible first example. Because I have a hydrogen and a hydroxide on my reactant side, you know what I'm going to do with my water? I'm going to separate it, and I'm going to make it hydrogens and hydroxides, because hydrogens and hydroxides make H2O. Just do it. I'm telling you, just do it. It's the easiest way to do it. Okay. Okay, so I'm going to go backwards. And now let's balance this guy. Go ahead. You balance it. Press pause. You balance. And now I'm going to balance it and explain. And you're going to come back and see if you did the same thing I did. I see that I have, oops, oh my goodness gracious. Oh my goodness gracious. I hope you didn't do that. I see that I have 1 lithium here. I see that I have 2 lithiums here. So I will put a 2 here. I now see that I have 2 OHs here. Over here, I have 1 OH, so I'll put a 2 here. I'm going to go back to the beginning. I have 2 lithiums, 2 lithiums, good. 2 hydroxides, 2 hydroxides, good. I'm going to clean that up. All right, go to my next. I have 2. Remember, there's an understood 1 right here. 1 times 2 makes 2 hydrogens. And over here, I have 2 times 1 makes 2 hydrogens. All right, so those are good. I haven't changed anything. So I'm going to go straight to my sulfates. Remember, there's an understood 1 right here. 1 times 1 is 1 sulfate. Okay, and over here, there's an understood 1. Recall there's an understood 1 right here. 1 times 1 is 1 sulfate. My equation is balanced. Get rid of my excess. I don't need my 1s. And there we go. Excuse me. Okay. Let's do it again. Now, magnesium reacts with sodium fluoride to produce magnesium fluoride and sodium. Okay, so what I want you to do is, let's do this together, okay? Make sure you have your periodic table. So, magnesium. That's magnesium. Magnesium is by itself. Is magnesium diatomic? No, because those are my diatomic elements. And magnesium is not one of them. So I'm good. I'm just gonna, it's just magnesium. It's probably a solid because it's a piece of metal. Magnesium is a metal. Reacts with sodium fluoride. That's ionic. Sodium has a charge of 1, and fluoride has a charge of 1. So that's NaF. Okay? Magnesium reacts with sodium fluoride to produce, it's my arrow, magnesium fluoride. Okay, well that's ionic. So I need symbols and charges to get my subscripts. Magnesium is a 2. Fluoride is a -1. That makes MgF2. And means plus elemental. That's fine. Just the element, sodium. It's by itself. So you have to ask yourself, is this diatomic? No, it's not. It's not one of our up there. Okay. So what we have right here, right, is it's called a skeleton equation. It is not balanced. We must always balance our equations, and not until they're balanced can we call them a chemical equation. Chemical equations are balanced, okay? So I see I've got 1 magnesium reacting. Why don't you, right, what you need to do right now, I hope I wasn't covering up that HOH, is you need to pause. You need to balance this guy. You need to come back, okay? So I see 1 Mg here, 1 Mg here, 1 Na, 1 Na, 2 Fs, 2 Fs, 2 Nas, 2 Nas, Mgs are still good. Okay, that's what you should have. All right, let's go to the next one. If a copper coil, okay, so copper is placed in, added to, silver nitrate, silver crystals form, and copper 1 nitrate is generated. All right, let's write that sucker. Copper coil, copper's by itself. Is it diatomic? No, it's not bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine. Copper's a metal, it's a solid. It's placed into, it's added to a solution of silver nitrate. That's ionic. I need symbols and charges to get my formula. Pause and go figure out what silver nitrate is. Pause and get silver nitrate and write it right here. Silver nitrate is ionic. Silver has a charge of +1. Nitrate is on the chart. It's an 8. It's negative. Silver nitrate is AgNO3. Okay, silver crystals form. So what you need to do is, what are you going to write if something forms? That's correct. We're going to write an arrow. Silver crystals would be silver, just silver. This says a solution, so that's aqueous. And plus sign copper 1 nitrate. All right, that's copper with 1 charge. Nitrate is also a 1 charge, CuNO3. That would be a solution, and there's no way you would not be expected to know that right now, okay? So, and if you look, go and balance it, pause, go balance, pause, go balance. Okay, are you back? All right, it's already balanced. It's already balanced. You don't have to do anything. 1 to 1 to 1 to 1 to 1. It's already balanced. Let's do this again. Crystalline. Woo, look at that, guys. C6H12O6. Crystalline, solid. Burned in plus oxygen. It's by itself. What do you have to ask yourself? Is it diatomic? Wrinkle. Hoff. Oh my goodness, it is diatomic. Anytime something's by itself, ask yourself, is it diatomic? Yes, it is. Therefore, give it a 2. It's by itself. There's going to be 2 of them bonded together. It's a molecule, a diatomic molecule. It's 2 atoms bonded together. It is a molecule. It's a gas. And carbon dioxide and water vapor are formed. So we will form carbon dioxide. This is covalent. I don't need charges. The prefixes tell me the formula. Carbon dioxide, that is a gas. And water vapor, that's H2O in its gaseous form. Oh my goodness, we have to balance this guy. Pause, balance, I'll balance. Let's see how it goes. Remember, it's trial and error. I make mistakes. See how you do, we'll see how we do. I'm gonna put a 6 here. I'm gonna put a 6 here. That's 12 plus 6 is 18. I'm gonna put a 9 here. All right, come back. You're back. That's what you should have. Let's keep going. The more you do, the better you get. Don't forget, anytime something by itself, ask yourself, is this diatomic? Calcium carbonate combines with hydrochloric acid. They don't need to tell you that. You should be able to figure it out yourself. To produce calcium chloride, water, and carbon dioxide gas. All right, let's jump in here. You get started. We need calcium carbonate. Pause. Write your formula for calcium carbonate. Calcium is a metal. This is ionic. I need symbols. I need charges. Those are going to cancel. It will be a solid. All right. Combines with hydrochloric acid. For some reason, they told you what it was. It's binary. Therefore, it's hydrogen with another element. It's hydrogen with chlorine. Acids are aqueous. To produce calcium chloride, pause, get your formula for calcium chloride. And then come back Calcium is a metal. It's ionic. Chloride, elemental, monatomic ion, CaCl2. It's going to be aqueous. And water, H2O, is a liquid. And carbon dioxide, we have a covalent. Di prefixes tell us the subscripts, and that's a gas. Look at it and see what you might need to do to balance, okay? There you go. Just put a 2 right there. Okay, if you're confused, these oxygens add up right here. There's 1 and there's 2, 3. So there's a total of 3 over there, which matches your 3 right here. Everything else is pretty simple. Okay, let's go down and let's look at the next few. The more you do, the better you are. All right, zinc and lead 2 nitrate react to form zinc nitrate and lead. All right, zinc. By itself, what do you ask yourself? Is it diatomic? No. Leave it alone. And plus lead 2 nitrate. Pause. Get the formula. I'm going to walk through it. If you don't get what I get, lead 2 nitrate, Pb2 plus, NO3 negative, PbNO3 2. React to form is an arrow. You should be back now. Zinc nitrate. All right, get the formula. Come back. Zinc, Zn2 plus, always a 2 plus. That's why they're not telling you. NO3 negative gives me Zn, NO3 2, and plus lead, Pb. It's by itself. Is it diatomic? No. There is our skeleton equation. It is not a chemical equation because it is not balanced. However, let's look at it. Is it balanced? Make it balanced. Come back. It's balanced. It is a chemical equation. It is already balanced. If you don't understand that, please ask. Let's continue. Aluminum bromide and chlorine react to form aluminum chloride and bromine. All right, this is ionic. Most often it's going to be ionic for you guys. So let's get symbols and charges. Aluminum, 3 plus, bromide, front. We're going to have AlBr3. Notice I can't have any charges with my answer, okay? So I got to get rid of this stuff. And chlorine, all right? So and is plus, Cl is chlorine. It's by itself. Is it diatomic? Yes, it is. Therefore, it gets a 2. All right, reactive form. That's our arrow. Let's clean this up. No charges. Aluminum chloride. All right, that's ionic. We need symbols and charges. Aluminum, Al3 plus, chloride is that. So we have AlCl3. Let's get rid of that. And plus sign. Let's put it right here. Bromine gas. Bromine is Br. It's by itself. Is it diatomic? Yes. Therefore, what do we give it? A 2. Okay? It doesn't have to be hard, guys. It doesn't have to be hard unless you've never learned to write formulas for compounds. And I told y'all you're going to have to, it's going to come back. Okay? Let's balance it. Here, 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 here. What you need to do is you need to pause. You need to balance it, and then come back. Check it. Your answer should look like this. That should be your answer. Okay? All right, let's do a couple more. Sodium phosphate. It's ionic. You need symbols and charges. We got Na plus, PO4, 3 negative. You should be able to easily see what that comes together to make. All right, and plus sign, right? I'm going to do less this time. Calcium chloride, ionic, symbol charge, CaCl2, react to form, plus calcium phosphate, calcium. Phosphate is a polyatomic, PO4, 3 negative. Did I just start going too fast, guys? I'm sorry. You should have paused anyway. I'm sorry. Ca3, PO4, 2. And sodium chloride, NaCl. NaCl, both are ones. That's simple. Symbols, charges. We worked on it, we worked on it, we worked on it. All right, now we have to put and balance this. Pause, go away, come back, and make it and check your work. 2, 3, 6. Okay, that's what you should have. If you don't understand, you can ask, why is that balanced? Try to figure it out, all right? Okay, let's do this again. Potassium metal. Okay, you do it, come back. You do it, come back. Potassium metal. Potassium, is it diatomic? No. Metal means solid. And chlorine, is it diatomic? Yes. 2, gas. Combine to form potassium chloride. Potassium is a 1, chloride is a 1, 2, solid, because I know it's ionic. It'll be a solid. I need a 2 here. It's balanced. Aluminum. Aluminum. Pause, do the rest, come back. It's by itself. Is it diatomic? No. It would be a solid. And hydrochloric acid, hydro, binary, hydrogen, and chlorine, chloride, HCl, react to form arrow, aluminum chloride, ionic, symbols, charges, AlCl3, and plus hydrogen gas. It's by itself. Is it diatomic? Yes. Give it a 2. Same steps over and over and over, all right? Balance it. Pause, you balance, come back, and let me know if that's not what you have, okay? Last, oh my gosh. You do those, you bring them back, okay? Okay. Bye. Bring your questions. You should have them. You should have them.